All right. Hello, Ellie. We are, we probably have like 2 days left in this chapter or this section, and this is R8. This is the last section of the chapter. We'll probably do 2 more days of this just because we have shortened periods today, and I don't know, tomorrow I guess we're a little bit short because we have 8 to grade. But what we'll do Thursday, Friday is we'll have review, and then Monday we'll kind of maybe do some whiteboards and finish review, and then test on Tuesday over chapter R, which is huge. Okay, so here we go. We are on, they have like right here in this little box, they have rules for radicals. Okay, here we go. All right, let's do this. Let's say you have the cubic root of x squared times the cubic root of y. Okay, this first product rule says that I am allowed to put those together under one roof as the cubic root of x squared y. Okay, like if they're both cubic roots, I can just shove them all together. Okay, now in the same way, here's another example of this. Let's say I have the fourth root of, I don't know, 4 times the fourth root of, yeah, but the fourth root of 64 doesn't come out nicely. There we go, let's do that. The fourth root of 4 times the fourth root of 4, whatever. You can't take the fourth root of 4, true? Like, there's nothing times itself 4 times that will give you 4, right? But what I can do is I can multiply those two together because they're both fourth roots, and that would be the fourth root of 16. Now, what do you take times itself 4 times to get 16? 2. So that one does come out nicely, right? So as long as they're the same root, you can put them together, right? And it comes out that way, okay? All right. Division works the same as well. So, like, let's say I have... And you can break these apart too. So a lot of times when we go to simplify this stuff, like this guy, if I have like the cubic root of 27x to the third, y to the sixth, right? Let's say I have the cubic root of that going on, right? I like to split it up, and I do the cubic root of 27 over here, and I do the cubic root of x cubed over here, and I do the cubic root of y to the sixth over here. Okay? Do you know what the cubic root of 27 is?
No.
3. 3 times 3 times 3. What's the cubic root of x cubed? Just x. What's the cubic root of y to the sixth? Y squared. So if I shove those now back together, it's 3xy squared. Okay? So I can put them together and break them apart as long as they're the same root. Okay? Now the same thing works with quotient or division, right? So we had the other day, we had like the square root of 49 over 64. Okay? Just as an example. Square root of 49 over 64. You can do those individually as the square root of 49 over the square root of 64, which does come out nicely. The square root of 49 is 7. The square root of 64 is, so it's just 7/8. You just do those individually. Done. Perfect. Very good, very good. In addition to that, you can shove together in the same way. So let's say I have the square root of, I don't know, 50 over the square root of 2. How do you do that? Now that are already apart, if I put them both together, it would be 50 over 2, which is the square root of 25, which is 5, right? Like you shove them both together under one roof. So I can tear apart and shove together as long as they are the same root, right? If one's a cubic root and one's a fourth root, I can't do that. Or one's a square root and one's a fourth root, whatever. I can't do that, okay? But you can shove together and you can pull apart. All right, here is something that's very interesting. All right, let's say I have x, and let's say I have the square root inside of the cubic root. Ugh. Like I have a square root inside of a cubic root. Heavens to Betsy. All right, here we go. One way to think about this is that the square root, this guy inside here, this pink one, is x to the 1/2 power, right? Make sense? X to the 1/2 power. Okay, what's the third root mean? 1/3 power. Now what do you do with these exponents? Multiply. What's 1/2 times 1/3? 1/6, 1/6, and that is now the 6th root of x. That's what he means, right? So in other words, when you have a root outside of a root and all the things, right? This is a cubic root, this is a square root. What do you do with these two numbers? Multiply, right? 3 and 2. He now makes the 6th root of x. Gross. Disgusting. So that's what they're saying here. If you have the mth root and the nth root, all I have to do is put them under one root, and it is m times n. Okay? Good? Good. Okay. Lots of rules. All right, here we go. Use the rules for radicals to perform the indicated operations. Assume all variables and expressions represent positive real numbers. Okay, great. A, what shall we do first? I want to multiply them together. I mean, you could try to break them down, but let's multiply them together first. What's 6 times 54? 324. Does the square root of 324 come out nicely? What is it? 18. Perfect. Done. Don't try to break them down first, because 54 is like 9 and 6 and blah, blah. No, we don't want to do that. Okay? 18. Done. Okay, B. Oh my gosh. All right, they are both cubic roots, and we have an m underneath it here and an m squared here. Yeah, so it'd be the cubic root of m to the 3rd power, because we're adding those exponents, we're multiplying together, right? But then what does that come out to be? Just m. Yeah, right. You can't take the cubic root of just m. You can't take the cubic root of m squared. When I multiply them together, it's m to the 3rd, which just reduces to m. Nice. Okay, C. This is gross. All right.
77xy.
The square root of 77xy. All right. Can you take the square root of 77 or break it down? I don't think so. Like, is there a number that goes into 77? Square root of. It's just 7 and 11, and 7 and 11 are both 9. So I don't know if it works. We can't pull any y's out, right? We can't pull any x's out. So he's just the square root of 77y, xy. Okay, over here. I don't think 7, you could try, but 7 and 64, those aren't nice numbers.
Can you just leave it?
So it'd be like the square root of 7 over the square root of 64. Square root of 7 doesn't come out nicely, so it'd be the square root of 7 over the square root of 64 does come out as 8. So the 8 would pop out of the square root, but the square root of 7 would not. Yeah. Very nice. Very nice. How about that? Okay. All right. What about E? That's kind of similar to what D was. We're doing the 4th root. So the 4th root of A over the 4th root of B to the 4th.
So the 4th root of A over B.
4th root of A over, and B does pop out, so 4th root of A over B. Done. Nice. Very nice. You see how that works? Okay, F.
20.
The 21st root of 2.
Which would be
Like 2 to the 1 over 21 power. Like, that's what he would look like.
According to the calculator, it's 1.0335577.
Okay, say that again. Don't. 1.0335577.
77. 83, and that's the farthest my calculator
83. Okay, so if you take this number times itself 21 times, that gives you 2. Weird.
I'll take it to the 21st power.
Does
Yeah,
it
gives
come
me
out
2.
2 exactly? Yeah. Because your calculator has in there the full decimal all the way out. If I would try to type this back into my calculator and have it rounded off at this decimal, it probably wouldn't give me 2 exactly. But since your calculator already has that number in it, will do that. Yep. Okay, but the answer is the 21st root of 2. Okay? What? I don't know. They go through and they test out so trial and error, right? Like what number do you take times itself 21 times to get 2? I know it has to be a number smaller than 2, right? And it's got to be 1 point something, because if it was like 0 point something, 0.7 or whatever, if you take numbers that are less than 1 times itself infinitely many times, it actually becomes a smaller number. Does that make sense? Like 1/2 times itself, like 1/2 times 1/2 is actually 1/4, which is smaller. So numbers that are smaller than 1 end up getting smaller when you square them or cube them or take them to the 4th power or whatever. So I know it has to be a number bigger than 1, right? So what it will do is it will take like 1, like it will test this out, 1.1, and it will take 1.1 times itself 21 times. And if that's a number bigger than 2, it's like, nope, we got to go 1.01, right? And it will take it times itself 21 times, right? And then it will like continue going out as far as you can, and it does that all in like a second. Like it keeps troubleshooting to try to figure out what that decimal number is. Yeah, weird stuff. And a calculator does it all in like 1 second. So anyway, there you go. All right, that was F. G. Ooh, what's this one? It is the 8th root. Yeah, because don't forget that this is a 2. Okay, if it helps you put a 2 in there, go for it. 4 times 2 is 8. 8th root of 3, which is some ugly decimal number, whatever, but we'll just leave it as the 8th root of 3. Okay?
You can't even do that one. 'Cause
Yeah, 8. Or H, can we do that? So what we could do is if this was the square root of... No, we couldn't even do that either. We couldn't even do that either. Yeah, this is done. We can't do anything more. Because one's a square root, one's a cubic root. We can't do any of that. Boo.
I tried to
Okay, yeah, right. All right, next. Example 6. Simplifying radicals. I feel like we've been doing this already. Like, we've done this before, right? That whole thing? 175. What goes into 175 that you can take the perfect square root of? If you need to, make a list, like off to the side, like this helps. So I'm going to go X. Do this for me. Let's go in X column. Let's go in X squared column. And let's go in X cubed column. Okay? If you need to, make this list because this helps. Okay? So let's start with 1. If we go 1, 1 squared is 1. 1 cubed is 1. Right? Then if we go 2, 2 squared is 4. 2 cubed is 8. You see what I'm doing? Am I going too fast? I'm going to go 3, 4, 5, 6, 7, 8, 9, 10. We'll go 11, 12. I don't know. How high do you want to go? 13, 14, 15, 16. Yeah, 16 should do it. Okay, we won't cube all the way, but we'll square all the way. All right, let's do our square column. 3 squared, 9. 4 squared, 16. 5 squared, 25. 36, then 49, then 64, then 81, then 100, then 121, then 144, then, yep, 169, 14. If you know 169, you got 196. They're flipped. Yeah. 15?
225.
225. 16?
256.
256. How high can you go? I know 17 is 289. I don't know 18. 18, I think, is like 343 or something. I don't remember what it is.
324.
324. Okay. I can never remember 18. And I can never remember 19, but then I know 20.
I go up to 16 and then I stop.
Yeah. I know 17, but I don't know past 17. But then I know like 20, obviously, and 30 and 40. Those are just whatever. Okay.
The easy ones.
Yeah. All right, let's do x cubed, just a few, because we won't go all the way down, because they're just too big of numbers. What's 3 cubed? 27. 4 cubed? 64. Yep. You're really just taking these numbers times each other to get the cube one, right? 5 and 25 makes 125. 6 and 36 is that like 216, I think?
Yeah.
216. 7 and 49. I know. 729, 343.
And then 512.
512. 729 and 1,000. Okay, we'll stop there.
I don't.
We'll stop there. Yep. You're not going to see any cubic roots or anything that are bigger than 100 or like bigger than 10 when you're trying to break down. Okay. So that's helpful. That's a little helpful. All right, so when we're doing the square root of 175, okay, I'm looking at my square root column right here. And I'm not looking at any numbers past like 169, obviously, right? But I want numbers that are underneath of there that go into 175. What goes into 175 that you can take the perfect square root of?
25.
25 and
7.
7? Yes, 25 and 7. Yeah? Okay, what is the square root of 25? 5. And the square root of 7? Just stays the square root of 7. So 5 square root of 7. Yeah? Perfect. Perfect. What? Yeah. Okay, the fifth root of 32 means what do you take times itself 5 times to get 32? Now, we didn't do an x to the fifth column, but the fifth root of 32, does it come out nicely? Is there something you can take times itself 5 times? I think it's 2 maybe. 2 times 2 times 2 times 2 times 2. This makes 4, this makes 4. 4 times 4 is 16 times this last 2. You betcha, is 32. So, the fifth root of 32 is 2, but what about this negative 3 in front? You multiply, so that makes? Negative 6. That's all. That one came out perfectly. Okay, and now they get a little bit harder. This is a little bit lumpier. Okay, there are 4 pieces underneath of that cubic root, right? So I'm going to split them up. The cubic root of 81. These are like little puzzles for me. The cubic root of x to the 5th power. The cubic root of y to the 7th power. And the cubic root of z to the 6th power. All right. Can you take the cubic root of 81 perfectly? Is he in our list over here? 81? No. Yeah. So what goes into 81 that you can take the perfect cubic root? 27 times 3 is 81? Okay, so we break it up just like this, right? But now instead of taking the square root, we're taking the cubic root, right? The cubic root and the cubic root, okay? So the cubic root of 27 is 3. The cubic root of 3 doesn't come out, so we leave them underneath, just like we do the square root thing. Does that make sense? Yeah. Okay, can you take the perfect cubic root of x to the 5th power? How do you know? Yeah, this has to be able to divide this number evenly, right? Like over here, let's cheat and go to z. This divides it evenly. So what do I take times itself 3 times to get z to the 6th power? Z to the 2nd power. I don't have to do like this process right here because it already pops out as z to the 2nd power. So I get to kind of bypass that step, okay? But these middle 2 pieces, 5 doesn't divide 3 evenly, 7 doesn't divide 3 evenly. So we got to do some stuff here. Okay, so how many do you want to put in the circle? What? Yeah, I'm going to put x cubed over here and I'm going to put x squared over here because together that makes 5, right? Because we're adding exponents. Okay, then I'm going to do the cubic root. I'm going to do the cubic root. What's the cubic root of x cubed? Just x. What's the cubic root of x squared? Just the cubic root of x squared. He stays trapped underneath, right? Okay, next. All right, how many can we put in the circle for the y's?
3 and 4. 6 and 1.
Let's go 6 and 1. 6 and 1, we want to go the most that we can. So I'm going to do 6 there, I'm going to do 1 there. Does that make sense? You want to do the highest you can, okay? So what's the cubic root of y to the 6th power? Y squared. And what's the cubic root of y to the first power? Just the cubic root of y, or cubic root of y to the first. Okay? So now we shove it all back together, right? Like what's on the outside and then what's on the inside, right? 3x. What else? Nope.
3x.
Yep. This cube goes on. This is an x cube. That's the cubic root. Yep. I see where your cube came from, though. So everything that's on the outside. The 3 is on the outside. The x is on the outside. Y squared. Z squared on the outside. Okay, what's on the inside?
3x squared and y.
You betcha. There you go. Disgusting. Those take a little bit of patience. You have to like slow down to do those quite a bit. Okay. Good.
We should stop
Stop there? You think so? Yeah, but then we got a lot left. Can we do one more?
Yeah.
Let's do one more. We'll do one more. Simplify each radical. Assume all variables represent positive real numbers. Okay.
If it's just 3 to the 3.
You're close. This guy right here and this guy right here. One of them is a power, the other one is a root. So this will be 3 to the something over something power. Which one? 2 over 6 power, right? The 2 goes on the top, the 6 goes on the bottom. So 3 to the 2 over 6 power. Now, the deal here is 2 over 6 can reduce to 1/3. Okay, now let's put him back. What's 3 to the 1/3 power?
3 down a third. Or 3. What I said backwards.
The cubic root of 3, right? If I put him back underneath of the square of the root, he's now to the. So it's just like I reduced those. 6 and 2 became 1 and 3, right? There he is. He's all better. Okay. Oh, we can do this. I think. So if I do the 6th root of x to the 12th, and I do the 6th root of y to the 3rd, if I separate those, what's the 6th root of x to the 12th? Does it come out nicely?
Yes.
How do I know? Because 12 divided by 6 is, so he's x squared. I don't have to hang any off in the circle or anything like that. It's just x squared. Okay, what about the 6th root of y to the 6th power?
It'd be y to the 1.
Yeah, I can reduce this. This can become a 1, this can become a 2. So it would just be the square root of y, right? I can reduce like that. Or if it helps you to think about it this way, it'd be y to the 3 over 6 power, which is y to the 1 over 2 power, which becomes that. Okay, now let's shove it together. What does it look like?
X squared.
X squared?
Squared.
Square root of y. There he is. Oh! That was it. Okay, we'll start on C tomorrow. I get so confused with these short periods. Ugh. Okay, bye, Ellie.